Question 1. Based on the histogram shown, which of the following statements is true? Look carefully at how the data are distributed across the intervals. Pay attention to where the data values are most concentrated, and remember what information a histogram can and cannot provide. Let's analyze what we can tell from the histogram. The bars show how many data values fall within each interval. The tallest bar appears in the interval from 20 to 30, which means more data values occur in this range than in any other. Now consider the answer choices. The median cannot be determined precisely from a histogram, because we do not know the individual data values within each interval. So any statement claiming a definite median location cannot be confirmed. We also cannot conclude the exact relationship between the mean and the median without knowing the individual data points. Likewise, the graph does not provide enough information to confirm a strong skew in either direction. What the histogram does clearly show is where the data are most frequent. Therefore, the statement that must be true is that the most common values fall between 20 and 30. Question 2. A dataset is summarized in the histogram below. One additional value, 80, is also included, but it is not part of any bar. Which of the following is most likely true about the dataset including the outlier? A. The mean increases significantly, but the median stays nearly the same. B. Both the mean and the median increase by the same amount. C. The mode becomes 80 because it is the largest value. D. The median becomes larger than the mean. Take about 30 seconds to think. Focus on how a single extreme value affects mean, median, and mode. Now, let's go through the explanation for question 2. The correct answer is A. The mean increases significantly, but the median stays nearly the same. Here's why. The median depends on the middle position of the data when the values are ordered. Adding one extreme value like 80 puts something at the far end, but it usually does not change which value is in the middle, so the median is barely affected. The mean, however, uses every value. When you include an outlier, you add a large number to the total sum, and that can pull the mean upward a lot. So the mean increases significantly. Also notice why choice C is wrong. A value does not become the mode just because it is the largest. The mode is the value that occurs most often, and a single occurrence can't be the mode unless it ties or beats the highest frequency. So with an extreme high value added, the mean rises, the median stays about the same, and the mean ends up exceeding the median. That matches choice A. Now, let's look at question 3. The histogram below shows the test scores of two classes. Both classes have a similar center. The question is, which class shows greater variability, and why? Before you answer, remember the hint. When comparing variability, do not focus on how tall the bars are. Instead, compare how wide the distributions are and how far the scores spread from the center. Now, let's go through the explanation for question 3. The correct answer is class B. Both classes have a similar center, which means their typical scores are about the same. However, class B's scores are spread over a wider range. You can see that the bars in class B extend farther to the left and right of the center compared to class A. This wider spread tells us that the scores in class B vary more from student to student. The key idea here is important. Variability depends on how spread out the data is, not just where the center is. Now, let's move on to question 4. The box plots show the test score distributions of two classes. Both classes have a similar center. Take a moment to study the box plots carefully. Focus on how the data is spread, not just where the center is. Which class shows greater variability, and why? Remember, with box plots, variability is about how spread out the values are, especially in the middle 50% of the data. Now, let's walk through the explanation for question 4. The correct answer is Class B. Class B shows greater variability. First, notice that both classes have the same median. This means their centers are the same, so the typical score is similar in both classes. However, when we look at the boxes themselves, Class B has a noticeably wider box. This tells us that the interquartile range, the middle 50% of the data, is more spread out in Class B. In addition, the whiskers for Class B are longer. This indicates that the overall range of scores extends farther from the center. Putting this together, even though the medians are the same, Class B's scores vary more widely. Key takeaway: when comparing box plots on the SAT, look at the IQR first. Greater width means greater variability. Now let's move on to question 5. The histogram shows the test score distribution for a class. The distribution is skewed and includes an outlier. The question asks, which measure of center is most appropriate for describing the typical score, and why? As you look at the histogram, notice the overall shape of the distribution, and also pay attention to the unusually high score on the right side. Take a moment to think about how this extreme value might affect different measures of center. Now let's walk through the explanation for question 5. The correct answer is that the median is the most appropriate measure of center. Here's why. First, look at the overall shape of the distribution. Most of the test scores are clustered between about 50 and 80, but there is a single high outlier on the right side, around the 90s. This makes the distribution right skewed. When a distribution is skewed, the mean is pulled toward the tail. In this case, the very high outlier increases the mean, even though most students scored well below that extreme value. The median works differently. The median depends only on the middle position of the data, not on how large or small the extreme values are. Because of that, the median remains close to the center of the main cluster of scores, and is resistant to the outlier. Now think about what the question is really asking. It asks for a measure that best describes the typical score. The outlier does not represent a typical student in this class. So a measure that is strongly affected by that outlier, like the mean, would give a misleading impression of the class's performance. That is why the median gives a more accurate description of the typical score year. Key SAT takeaway: when a distribution is skewed or contains outliers, use the median, not the mean. Now let's move on to question 6. Two lines are shown, and most of the points follow a clear upward trend. However, one point is far from the others. The question is, which line is the better fit for the data? As you think about this, don't focus on just one area of the graph. Remember the rule here. Consider all points, because even a single point can have a big impact. Now let's walk through the explanation for question 6. The correct answer is line B. At first glance, line A may look like a good choice. In the middle of the graph, several data points appear slightly closer to it, and visually, that can feel convincing. This is exactly where many students are misled. On the SAT, a line of best fit is not judged by where it looks good locally. Instead, it is evaluated by how well it fits all points overall. Now focus on the point in the upper right corner of the graph. This point is clearly separated from the main cluster. Although both lines miss this point, line A is much farther away from it than line B because that distance is so large. This single miss has a greater impact than several smaller misses elsewhere. In other words, one extreme error can outweigh many small ones. When you consider every point together, line B minimizes the total distance more effectively. That is why line B is the better fit for the data. Key takeaway: one outlier can strongly influence how a line is evaluated. On the SAT, always compare overall distance, not where the line looks neat. The best fit is the line that performs best across the entire dataset. Now, let's move on to question 7. This question is different from the previous ones. There is no graph. Instead, you are asked to decide which situation should be described using the mean rather than the median. As you read the choices, don't think about which measure is safer. Think about what the situation is trying to measure. Ask yourself, does this situation focus on a typical value, or does it involve a total or overall amount? Now let's walk through the explanation for question 7. The correct answer is C. Choice C asks about the average score used to calculate the total number of points earned by all students. In this situation, the total matters. To find a total, we need a measure that reflects every value in the dataset. The mean does exactly that. It uses all scores, adds them together, and divides by the number of students. The median, on the other hand, only tells us the middle score. It does not help us determine a total amount. The other choices all focus on a typical value in situations with extreme values. In those cases, the median is often more appropriate. Key takeaway: use the mean when totals or overall amounts matter. Use the median when describing a typical value in skewed data. Now, let's move on to question 8. Like the previous question, there is no graph. This time, you are asked to decide when the median is more appropriate than the mean. As you read each choice, focus on the goal. Ask yourself, is the situation trying to describe a typical experience, or is it focused on an overall total or average change? Now let's walk through the explanation for question 8. The correct answer is B. Choice B focuses on the typical commute time for workers. In many cities, most commutes are fairly similar, but occasional long delays can occur because of accidents or road closures. These unusually long delays are not typical, but they can significantly increase the mean commute time. Because the question asks for a typical experience, the median is more appropriate. The median describes the middle value and is less affected by rare but extreme delays. The other choices all involve totals or overall changes, where every value contributes to the final result. In those cases, the mean is the better measure. Key takeaway: use the median when describing a typical experience in situations where extreme values can distort the average. Now, let's move on to question 9. The same dataset is displayed using two different histograms. The only difference is the bin width. Take a moment to compare the shapes of the two distributions. As you do, be careful. Ask yourself not what the graphs look like, but what they actually allow you to conclude. Now let's walk through the explanation for question 9. The correct answer is C. These two histograms use different bin widths to represent the same data. Because of that, the overall shape of the distribution can appear different. With a smaller bin width, the data may seem to form multiple peaks. With a larger bin width, those peaks can blend together, making the distribution appear smoother. However, this change in appearance does not mean that the underlying data has changed. This is why conclusions such as, the data forms two groups, cannot be supported based on bin width alone. The key idea is that the choice of bin width affects how data is displayed, not the data itself. Key takeaway: when interpreting histograms, be cautious about conclusions that depend solely on visual appearance. Now, let's move on to question 10. The table shows the daily number of steps recorded by two students over 7 days. Student A's data includes 1 day with a very large number of steps, while Student B's data does not include any extreme values. The question asks which measure of center is more appropriate for comparing the typical daily activity of the two students, and why. Take a moment to look at both lists of values and think about how an extreme value affects different measures of center. You are not being asked to calculate anything here. Instead, you need to decide which measure best represents what is typical. Pause the video if you need more time. Let's go over question 10. The correct answer is B, the median. Both students recorded their steps over the same 7-day period, but there is an important difference between the two datasets. Student A has one extreme value, 20,000 steps, that is much larger than the rest of the values. All of the other days for Student A are clustered between about 4,000 and 5,400 steps. Because the mean uses every value, that single extreme day pulls the mean upward and makes Student A appear more active than they usually are on a typical day. The median, however, depends only on the middle position of the data, not on how large or small the values are. That means the median for Student A remains close to the typical daily step count, even with the outlier present. Student B's data does not include any extreme values, so the mean and median are already fairly close. Using the median for both students allows us to compare their typical daily activity in a consistent and fair way. On the SAT, this kind of question is testing whether you recognize when the mean can be misleading. When an extreme value is present and the goal is to describe what is typical, the median is usually the better choice. Now, let's move on to question 11. These two histograms summarize the same dataset, but they use different bin widths. Histogram A uses smaller bins, while histogram B groups the data into wider intervals. The question asks which conclusion is most appropriate based on these graphs. Look carefully at how the overall shape appears to change when the bin width changes. Your task is not to decide which histogram is better, but to understand what bin width can affect. Pause the video if you need more time. Let's go over question 11. The correct answer is C. Even though the two histograms look different, they are built from the same underlying data. The only difference is the bin width. When smaller bin widths are used, the histogram can show more detail. This may reveal multiple peaks or gaps, which can make the distribution appear bimodal. When larger bin widths are used, those details are grouped together. As a result, the distribution may appear smoother and show only one peak. This does not mean the data itself has changed. It means the way the data is grouped has changed how the shape appears. That is why conclusions about modality or shape must be made carefully. If a conclusion depends entirely on how the bins are chosen, it may not reflect a true feature of the data. On the SAT, this type of question tests whether you recognize that graphs involve design choices, not just raw numbers. Bin width is one of those choices, and it can strongly influence interpretation. The safest conclusion is that the apparent shape of a distribution can change depending on bin width. Question 12. The box plots below summarize the test scores of 3 classes. All 3 classes have the same median, but their score distributions are shaped differently. Which statement is the most appropriate conclusion? Now, let's go through the explanation for question 12. The correct answer is C. All 3 classes have the same median, so at first glance, they may appear similar. However, a box plot shows more than just the median. It also shows the spread and the shape of each distribution. Class B has a longer whisker on the higher score side, which indicates a right-skewed distribution. In a right-skewed distribution, the mean is typically higher than the median. This means that even though the medians are the same, the average performance in Class B is likely influenced by higher values. That's why the most appropriate conclusion is that Class B's mean is likely higher than its median. Question 13. The histogram shows the distribution of weekly delivery times for a shipping service. Most deliveries are completed within a few days, but there are some longer delivery times on the right side of the distribution. Which measure best represents a typical delivery time, and why? Now, let's go through the explanation for question 13. The correct answer is B. This distribution is right-skewed, meaning there are some unusually long delivery times on the right side. Because of those longer times, the mean would be pulled upward and would not reflect what most customers actually experience. The median, however, depends only on the middle position of the data. That makes it resistant to extreme values. So, when the data is skewed, the median gives a more accurate picture of a typical delivery time. This is why the median is the best choice here. Question 14. 2 classes took the same math test. Both classes have a similar median score. Class A has one extremely low outlier. Class B has no extreme outliers. Which measure is most appropriate for comparing the overall variability of the 2 classes, and why? Now, let's go through the explanation for question 14. The correct answer is B. This question is about comparing variability, not center. Although both classes have similar medians, their distributions are different. Class A includes an extremely low outlier, while Class B does not. If we used the range, that single extreme value in Class A would strongly affect the comparison. The range measures the full spread, so it is very sensitive to outliers. The interquartile range, or IQR, focuses on the middle 50% of the data. Because it ignores extreme values, it provides a more reliable comparison of how spread out the typical scores are. For this reason, the IQR is the most appropriate measure of variability in this situation.